This is one of the most difficult decisions I had to make in this series is what comes first. Do we talk about Call Manager Express, or what Cisco now calls Cisco Unified Communication Manager Express, which is the most long, absurd name of any product I've ever heard, so I rebelled and kept CME down here as kind of the theme of this. Do we talk about this first and talk about the local area network and the phones and voice VLANs and all that? Or do we talk about the dial plan first and digit manipulation and all those kind of things? And I seriously, it's kind of like flip the coin, see which one goes first. There's so many feelings I have both ways of like, well, it's best to have the LAN set up first and, local calling and then go to the WAN and yeah. But to really get local calling, you have to understand digit plans and manipulations, and here's the caller ID. I mean, so here's why I'm telling you all this. You may be seeing this series and this comes first. But it's not the way it was originally. I may decide to just flip this around and put CME as one of the first topics right after we talk about the voice over IP foundations and all those topics, and then get into the dial plan. Or you may come out, and this is the way I originally recorded it, to where we go through all the dial plan stuff first and then get into CME. So regardless of which order it's in, just know that you were the result of a coin flipping and it landing on heads. With that being said, what are we talking about here? We're talking about Cisco Unified Communication Manager Express. I'll just call it from henceforth CME. Because it's so much easier to say that way. I'm going to talk about the IP phones that exist in the world today, what their characteristics are, what to look for when you're buying IP phones, and we're talking about setting up the local area network. Then configuring the network to support IP phones. What are some of the things you have to design and think through? And then I would say the most important topic of the day is going to be this one, Cisco IP phone boot and registration process. This is where almost all of your troubleshooting comes in when you're trying to figure out why is that phone not working correctly. It is often said that without vision, people perish. And that's true in life as well it is in our IP telephony network. You have to have a big picture of where are we going? What is this product that we're talking about, this CME or CUCME, that we're looking at. Again, going back to the very beginning of Cisco's goal, they wanted a product that they could bring into a small to mid-size office that is literally an all-in-one device, to where it can run your data network, it can run your switch infrastructure, it can run your phone system, your voicemail, all kind of like the whole kit and caboodle. It's all in one place, and they called that product CME. And then renamed it CUCME. But I told you I was only going to call it CME from here on out. So what this is, and I showed you a picture in the front, you've seen it a couple times, is a router that is equipped with a feature set. It is really just an iOS feature set allowing it to support IP phones. So you could have, for example, a 2900 series router. Or I've got one here in the room, a Cisco UC520. And you could have an iOS on that does not support IP telephony in any way. And it will not support phones. You'll type in the commands, they'll say invalid command. It can be just the data router, but simply with a software upgrade. So this is not a hardware feature, nothing. I mean, this is just a software upgrade. You can now allow that same device to support IP phones, to give them the intelligence that they need to dial and to support dialing plans and everything that we've been talking about up till now. It's just an iOS feature upgrade. Now, with this device comes an upgrade of the entire data network, or I should say a replacement. And that's one of the big things that Cisco's pushing for is we want to get in from the beginning here. We want to get into a smaller mid-sized business before they go buy a traditional phone system and put traditional phones in. Why? Because it's so much more efficient, and of course from a Cisco business perspective, everything comes from us. We give you the phones, we give you the switches, we give you the routers, we give you everything that you need for any kind of data communication on this now unified network. Now, coming back to where are we going with this? Well, what we're going to be doing is configuring this device to support our IP telephony network, but before we can even get there, we need to support the network infrastructure. The switch has to support a variety of features, the key ones that I've listed right here. First one being power over Ethernet. Power over Ethernet allows you to plug in an IP phone and it literally powers on from the switch port. It sends electricity down the wire to do that. Now, they keep coming out with new power over Ethernet standards, and let me give you the evolution. The original was Cisco inline power. It was proprietary. And if you're shopping on eBay for some lab equipment, beware. There are some Cisco switches that only support the Cisco proprietary standard, which does not work for a lot of third-party devices. And nowadays, there are even some Cisco manufactured devices that don't support that original proprietary inline power standard. That was before there was a standard. Now, quickly, the industry evolved and saw the need for power over Ethernet standards so that we could have one switch supporting all kinds of different vendor devices. And so the industry responded with 802.3AF. And what that is a standard supplying up to 15.4 watts of power over a normal Ethernet cable. Now, that's pretty powerful, no pun intended there. That's pretty powerful because now we can start connecting devices that use a low amount of energy, like just all these Cisco IP phones, a lot of wireless access points, a lot of video cameras. There's a lot of stuff that you can get away with PoE technology with 15.4 watts, but there are also devices that can't do that. Like, for example, if you take an IP phone and start adding expansion modules that allow you to have more lines, like for a receptionist console or something like that, it loses the ability because it no longer can supply enough power to handle the expansion modules through that phone. So new standards have been created. There's now 802.3AT. That is now doing 25 watts of power over a normal Ethernet cable. I don't know how they do this. I'm a network focused guy. I don't know how do you get power over an Ethernet cable to even begin with, but then how do you make it more? Are they going to get to a point? I had somebody ask me the question. They go, "Do you think we'll start seeing PCs without plugs? To where PCs and monitors simply plug into a network cable?" And I thought, well, maybe. I don't know. I mean, when we get into the 25 watt plus range, we can then start powering some thin clients and some advanced devices with that amount of power. I don't think we'll, well, who am I to say? But I don't think we'll get to the point where everything comes over an Ethernet cable sort of thing, because I just think of the massive power supplies that the switches would have to be able to deliver all that amount of power. So one of the things you're thinking about with your switches is not only, can it support PoE, but can it give enough PoE? A lot of the chassis-based switches, you may put in enough switch modules that you exhaust the power supply, and now you're stuck because you have to upgrade your power supply before you can add any more devices. So all those kind of thoughts go into that. Another key switch role is voice VLANs. It is not only a best practice, but recommended by Cisco for a variety of reasons, but most importantly, two reasons: security. And, I forgot to talk about all this. Talk about that in a second. Security and quality of service. It is recommended to put your voice network on its own VLAN, meaning it's separate from the data network. So it's got its own subnet. So that, again, think about planning. You're going to have to provision an IP subnet for your voice devices. You're going to have to think about putting that VLAN across the network, allowing the switches or devices network-wide to support that VLAN. Or, we can start bridging into all kinds of switching design topics here. Cisco's more modern model of architecture is that we don't have layer 2 switches anymore. Everything, here's your distribution layer, and then we come down to the access layer with all of our access switch devices. And all of those are layer 3 devices, to where we don't have VLANs spanning the campus anymore. Everything's a routed network, which allows you lightning fast failover, allows you a more constrained failure domain. So if something goes wrong, you know exactly where it's coming from. So, there's all kinds of design concerns that come into this, but the key that we need to focus on is we need these devices on a separate VLAN. It provides for security, so our computers can't just tap into those conversations. If you can sniff a voice conversation, with a packet sniffer, you can easily get to it. I mean, gone are the days of the, ninja, Tom Cruise Mission Impossible hackers that are hanging upside down somewhere with alligator clips on a wire. It's kind of like, oh, those days are done. Now we have very nerdy looking people that are not as cool as Tom Cruise and not hanging upside down unless they really want to, sitting at their computer, sending rogue packets so that they can sniff the network. Because if they can capture that, they can get any phone conversation that's going on. So that's scary. So it's good to put it on its own VLAN. Now that you can also encrypt your voice, also a good practice. And quality of service. By having its own VLAN, we're very easily able to distinguish and say, oh, that's an IP phone. Okay, let's prioritize that over the data VLAN, which is a lot of times attached to the same switch port. That's the more conservative, money-saving design. So you can always prioritize the voice VLAN over the data VLAN. So that's a big one. Now, let me hit quality of service, then I'll come back to my little drawing down here. Quality of service is simply that. We'll talk about that later on in the series. There's a whole section on quality of service. It's prioritizing the voice traffic above the data traffic. Well, I mean, if you want to boil quality of service down, it is network discrimination. I would say that's probably the easiest way to say, this packet is more important than that packet. And that's all there is to it. So we want to be able to do that with our voice. So now let me talk about our different power standards that we have today. Power over Ethernet is the preferred. That's option 1 that you see right here. Option 2 is known as a power patch panel, or sometimes people buy an inline power coupler. You may have seen these, to where either the patch panel is plugged into the wall, like this, and getting power, and it can inject power down the wire. Or you can actually buy these little, they're literally Ethernet couplers. They're a little bigger. I mean, usually Ethernet couplers fit in your pocket. These barely fit in your pocket. And these plug into the wall and can inject power down just one line. And that's maybe if you just have a small deployment, you're not ready to upgrade your switch network yet, but you want to take advantage of power over Ethernet. And then, of course, the last one is just plugging your phone into a wall, and that will also deliver power to your phone and allow you to work that way. So all of these things, I mean, it's kind of like, welcome to the vision, right? All of these things have to be in place on the foundation before we're able to really start using and deploying voice across the network. So I want you to keep that vision in your mind. That vision we're going to continue to break down throughout this CME section and the rest of the series. I mean, we saw voice VLANs. I'm going to get into, well, how do you design that? How do you configure that? How do you set up DHCP for that, in each one of those? So let's start off with, well, we need phones, right? That's part of our vision. We have to have phones for users to use. What kind of phones do I get? Well, I looked back. Originally, I wrote the original CCNA voice book for Cisco Press, and that was back when the whole CCNA voice was on one product, and that was CME. And actually CUE, the voicemail module. So back then, I actually spent, and for CBT Nuggets, you can probably even find that original series on the site. I created 2 full 30-minute nuggets breaking down each phone model, what it supports, what features it had, and all that. And within a year, almost all of those phone models had been updated or replaced or modified in some way. So I made up my mind. I'm like, I'm not going to do that again. Instead, I'm going to cover the characteristics of the IP phone models that exist. And then you can apply, I mean, it's very easy to find out what phone models exist. You can go to Cisco's website. Matter of fact, I'll bring Chrome, just so you know where to look. Go to Cisco's website and go to products and services and voice and unified communications, and you just kind of poke around. There we go, voice products, IP telephony, and there we go. We've got all these different phone models that we can click on. So if you want to say, oh, well, what's the 90? Man, that thing's cool. Look at that phone. So I mean, that's an example of the 9900 series. So there are still some of the original series. I mean, when I got into IP telephony around 2001, 2002, I mean, they had the 7900 series IP phone, but all the original models, like the 7940, 7960, they're all gone. They're all replaced with the 41, 42, 45. I mean, all these models that have come out since then that are upgraded. So you can find out what models exist and what they have, but what do you buy? Well, it depends. It depends on whether you're setting up a lab environment where budget is the most conscious thing. I just want some dummy device. Maybe you're doing it in your house. You just want some phones to play with. Yeah, go grab the 7940, 7960. I mean, you can get those for well under $100. And that's, by the way, something to get used to. If you haven't been in the telephony world, things like $100 a phone shouldn't. You have to get to the point where it doesn't shock you. I mean, when I got into IP telephony in 2001, 2002, I mean, my house was Walmart phones. I think I paid $9 for the whole house of phones. But it's not uncommon in the PBX world to pay, $80, $100, $200 of phones, depending on the feature set that it supports. So the kind of features that you're looking at is, first off, is the phone single line or multi-line? Like I'm looking over here at this picture. I think that's a 7902 IP phone. Kind of scribbled the O there, but that's just a single line, great lobby phone. Same thing over here. That's a 7905. If I could write and talk at the same time. 7905 it gives you a more featurific display that actually supports XML, extended markup language, to where you can get simple applications developed for these phones and combine a lot of the services. For example, Cisco already has like hotel modules and applications to where in the in-room service you can do like room ordering for room service and have menus of dinners and check in, check out, order a movie, all those kind of things available from the phone itself as an XML based application. So single or multi-line, that's going to be one of your big decisions. What do your users need? Built-in switch, and I put a big watch for gigabit. Oh man, the majority of IP phones, and who knows, by the time you hear this, and I get back to that dating and things move fast, but the majority of phones currently today, nearing the beginning of 2013, are all 10100 megabits per second. So with gigabit on the rise now, and I would say beyond rise, it's there. Everybody's doing gigabit Ethernet all over the place. It'd be very painful to buy a whole bunch of phones that are 10100 only to find out in 2 years, the company is now saying, hey, we need gigabit Ethernet to the desktop, which now means, since all the computers are daisy chained from the IP phones, that you have to replace all of the IP phones because they're only 10100 speed. So you want to think about, do I want to invest in phones that have gigabit Ethernet switches involved? Color / touchscreen. A lot of, you can see just from these pictures, a lot of them are color, a lot of them are not color, and some of them are even touchscreen if you want to go to that level. Is that important to you? And you have to think about, why would I want, yeah, it's cool. Yeah, the CEO might want it, but why do I want that? I mean, is there applications that I need or use that have that color characteristic that I need? Video support. Do you want something like this? This is that 9900 series phone with a built-in video camera, or this is the original. I think Tandberg created that device to where it was a built-in video camera on there, and that's, I will say, it's happening. It is happening. Video telephony has been available for years, but the big question is why, and how. And you started seeing people roll out sites with video telephony capability, and they found out their users just didn't use it because they didn't feel comfortable with it. And I've got to admit, I've had the iPhone since the beginning, and one of the things on the iPhone that you probably know of is FaceTime, right? Or if you've ever used Skype and done video, we've all probably done video conferencing, and the first few times you do it, it's weird. When my wife has an iPhone too, and I pulled it up on my first trip away. I'm like, okay, I'm gonna be just like the commercial, right? I'm gonna be the father sitting on the bed in the hotel room and talking to his family. And I pulled it up, and I'm looking at my wife, and we're just staring at each other like silent, and we're kind of tilting our head, and we're like, hi. It's weird, but I would say, here I am 4 years later from that original video call with my wife, and now I'm like, why would you not do this? Like I prop my phone up on my dashboard on the way home when I'm driving, and I pop up FaceTime, and I'm it's probably not safe, but I'm talking to them over the cellular network, and my kids are like, hi daddy, and it's not weird to them. And before long, I'm saying all this to say this is going to become the norm, to where video it's going to be weird to call somebody and you're like, hey, I can't see you. I'm not saying that's today, but I'm saying it won't be long before it's weird to have phone calls where you don't see the other person. It's coming, I'm telling you. So conference stations. Looks like my little phone graphic got involved there. So conference stations, like this guy, you need some of those for the conference room. They have them. ATA adapter. This is actually an ATA 186. Because there's a single Ethernet port here, and this is two FXS ports. These, it looks huge, like look at that microwave size adapter, but really it's small. I mean, it's probably, compared to this phone, it's like about that size. You throw those in the little break rooms, areas where there's fax machines or modems, or you just need a couple analog phone ports real quick. The ATA 186 has a built-in 10 base T Ethernet port, which you might go, well, good grief, 10 megabits per second. And I say, well, good grief, 10 megabits per second. It's only two phones that this thing supports. So they have the ATA 188, same look and feel, but it has a built-in switch. That goes to 10100, and who knows? They'll probably have a ATA 189 or 90. They don't have it yet, but something that has gigabit Ethernet built in there, that built-in switch. I think that's going to be one of the big revolutions of all these devices. So ATA adapters, how many of those do you need? And then IP communicator. IP communicators over here. We actually saw it earlier in the series where I was using it to demonstrate some phone calls on screen. It's where you literally get a 7970 IP phone on the screen of your computer. First thing is, it's not free. It is licensed. You don't just get this IP communicator to throw everywhere for free. There's licensing to pay for it, but it does video telephony. You can integrate it with what's called the VT Advantage and do video telephony. I mean, there's all kinds of stuff that's possible. But this allows you to have complete freedom. I mean, somebody can have a laptop where they're roaming around the building, roaming around, depending on how you set it up, you could have them roaming around the United States, and they have an IP phone that works as if they were sitting in the office. So there it was. That was probably an hour plus discussion in the original CCNA Voice series from years ago on phone models boiled down to 8 or 9 minutes. So pick your phone, and then we now move into a hugely important topic that we'll revisit many times in this CME section, and that is the Cisco IP phone boot process. I emphasize it so much because this is really common where a lot of troubleshooting comes into play on your part. At least initially in the voice network, a very common problem is a phone boot cycling. You'll see it, do the Cisco logo, see some text, and then it starts over. The Cisco logo, you get some text flashing across the screen. What's going on? And the phone isn't going to be able to tell you too much. It's knowing what's happening behind the scenes that really is the key. So this is the 5 steps that the phone goes through as it boots. And again, as we break this down, as we expand that vision, we'll be configuring these different portions. But let's start off with number 1, the Cisco switch detects PoE capabilities. If you're using the 802.3 AF, the normal standard of today, 15.4 watts, it's actually going to use a little tiny amount of voltage that doesn't harm anything to see if there's an unpowered device attached. And if essentially that voltage comes down here, and if it is an unpowered device, we'll loop back to the switch, and that's how it's like, oh, you need power. Let me deliver some power to you down the line. So bzzz, a cable lights up in the phone. The phone, it goes into what I call Christmas tree mode, to where you see all the lights kind of cycling around. You see blue, green. It's kind of going through all of its boot process. And during that time, the switch will actually send the voice VLAN information to the switch via CDP. Now, that's interesting. CDP is the Cisco Discovery Protocol. Typically, I mean, when you see that, if you've come from the CCNA background, you're thinking, okay, show CDP neighbors or show CDP entry, and you get all that data of what devices are attached. Well, Cisco modified CDP, and they tweaked it to actually be a delivery protocol as well. So when this phone is powering on, this will send a CDP message down to him and say, hey buddy, you are on voice VLAN 110. Because remember, a lot of times it saves a lot of money in cabling to just run one Ethernet cable and daisy chain your computers from there. Now the way that's going to work is the phone itself tags its packets. So So think back, if it's been a while since you've seen VLANs, remember VLANs are what allow you to separate, devices from each other. It's a virtual LAN within your network. So I can say this computer's on VLAN 10 and this computer's on VLAN 20, and they literally cannot speak to each other, even though they're plugged in next to each other on the same switch. They're on different subnets completely. It's a great security boundary between them. Now the way that works is I can then daisy chain that computer or that switch to another switch and put devices on VLAN 10. Here's another device in VLAN 10 and VLAN 20 as well. And the way that the switches keep track of it is as frames or packets are sent across that line. Technically it's frames, but everybody says packets. It sticks a little tag on the header that says, hey, this is actually belonging to VLAN 10 or VLAN 20. So when it gets over here, he goes, oh yeah, you're VLAN 10. And so he can easily identify that. That's known as packet tagging. How about that? Packet tagging, or the standard is 802.1q of packet tagging. So this phone will tag its own packet. So as it starts communicating and asking for an IP address, DHCP request, as you're speaking on the phone and it's sending packets, it will take, here's, you say the word cow, it's inside of a packet. It's going to put a little tag on there that says, I'm part of VLAN 110. So when it gets to the switch goes, oh, VLAN 110, then I treat you this way. You get this level of quality of service. You've got these priorities. You route this direction, all that kind of stuff. Now the computer itself, clueless. Doesn't even know what a VLAN is. So it's just sending packets the way it always has. Those pass right through the phone and get assigned to whatever VLAN. You're back in this world. If that computer was decided to be on VLAN 10, then it ends up on VLAN 10. But the computer doesn't know. And computers never know what VLAN they're on. All they know is I can talk and surf the net because that's all people do all day. So he's on VLAN 10 simply because he sends things through untagged, or some people call it native VLAN. So what happens is this switch delivers the phone's VLAN to it via CDP. So now the phone says, oh great, I'm on VLAN 110. Now what if you have non-Cisco phones? What if you have non-Cisco switches? What do you do? Well, depends. If you've got non-Cisco phones, I would question why, but a lot of times they can use like a DHCP. Like there's an option you can configure on your DHCP server. Like maybe you do option, I don't know, it depends on the vendor, 89 or something. I say option 89 says 110. So when this phone boots up, it sends a DHCP request, gets a response back, and it goes, oh, option 89, it says I should be on VLAN 110. Let me set that and reboot myself. Or maybe you go phone by phone and you manually type in on the phone. I mean, there's many ways to assign the voice VLAN, some more painful than others, but man, Cisco makes it easy, as they should. If you buy Cisco switches and Cisco phones, they just do it, and they take care of it and assign it. So once the phone, I've scribbled all over this thing now. Once the phone, let me change colors, sends a DHCP, or sorry, once the phone gets its voice VLAN, it's on 110, it's going to send a DHCP request on that VLAN. It's going to say, hey, I need an IP address. And hopefully you have a DHCP server configured to respond on that subnet or on that VLAN. And we'll talk when we get into the configuration about helper addresses and how to do that. But when you configure your DHCP scope, especially for Cisco IP phones, you'll give them the subnet range. So I'll say, maybe this is 10.1.1.50 through 90 is the IP addresses. The subnet mask we'll say maybe is a /24, the default gateway, and DNS. I mean, all the normal options, but one of the huge keys is that you add option 150 to that pool. Option 150 is the IP address of the TFTP server in your network. Why do we need that? Well, see, these phones are not the most intelligent. They don't know where the call manager server is. They don't know where the CME router is. They need to be pointed that direction. They don't even know which firmware to use, if there's an upgrade available, or what language they should be speaking. I mean, all of these things that I'm rattling off are all part of a configuration file on the TFTP server. Now, in this picture, I have a server here. That's a TFTP server. I have a server here that's a DHCP server. But you know what? In Cisco's vision, all of these could be actually running on that CME router. That it could be the all-in-one device that is the DHCP. Matter of fact, that's the way we're going to configure it when we get into the configuration. But that configuration file is going to tell the phone all of those things, like what language do I speak, what firmware should I use, what is the IP address of the CME server. I mean, maybe you are running it on a separate server. Well, this isn't the CME router. That's not the CUCM server if that's what you're running. So that configuration file will point the phone to the next step. So once it looks in that, option 150, right? So option 150 tells it where to go. Step 4 is now the phone contacts the TFTP server and says, hey, give me my configuration file. And by the way, here is a little Who Wants to Be a Millionaire trivia. The phone will actually look for a file named SEP and its MAC address. And a MAC address is 12 characters dot, I think it's .cnf, not CF, CNF.xml. So what happens is, as you configure the phones, I say, okay, I want this phone to have 5 lines, and I want this phone to have this and that and this and that. The CME router will actually generate a configuration file for that phone and store it on the TFTP server. So if the phone has been configured, it will find that file, which is SEP and its MAC address. And now you might say, well, why the trivia? Well, many people will get stuck and they say, well, what's SEP stand for? And a lot of people are like, I've heard a lot of made up stuff, which of course now I can't think of any of them. The actual definition comes from the original manufacturer that Cisco bought to get into IP telephony, a company called Celsius, spelled with an S, not a C. Celsius Ethernet phone. And almost as a tribute of honor to that company, Cisco has kept that file name format for all of the years since then. I mean, this is Cisco didn't originally create Call Manager. They bought it. They didn't create the original IP phones. They bought them from another company by acquiring them. So that's where that comes from. So the IP phone downloads its configuration file, which tells it where to go to register. The final step is that the phone registers with the CME router. And I know some of you are like, wait a sec, that space wasn't there just a second ago. And some of you non-observant people like me probably didn't even notice. So the phone registers with the CME router. Now, what does it mean to register? Think of it like the phone is a soldier. It's like, reporting for duty, sir! And he's standing there in line. He's like, I'm ready. I'm ready to take calls. I'm ready. If somebody lifts my handset, I'm ready to play dial tone. I'm ready. So it's registered, and it's now seen as online. So when this, let's say this phone is extension 2001, when somebody on the network calls extension 2001, the CME router goes, oh, I know where that phone is. He's online. Let me send a ring signal down to him, and he now starts to operate. So knowing that whole boot process is key. I mean, it's going to be key to knowing how things work, and it's also key to troubleshooting. It will help you decrypt the messages the phones are giving you. Remember, I said a common troubleshooting error is boot cycling. I mean, they'll actually tell you, they're like, hey, I can't contact the TFTP server. And if you don't know the boot process, you're going to be going, well, why are you trying to do that? What's that? How come? So I mean, the key is, if you see the phone saying, I can't contact the TFTP server, it almost, with that error, it gives you more with what is working. Because I go, okay, so if it's trying to contact the TFTP server, that tells me Power over Ethernet's working, obviously, or I wouldn't see a thing. It tells me that the voice VLAN probably got delivered, I think, because it got an IP address from somewhere. It tells me that it is getting an IP address, and maybe it's even getting the IP address of the TFTP server, but maybe there's just some. So you see what I mean? It's almost like it eliminates a bunch of layers of troubleshooting just by seeing that it got to the point where it's trying to contact the TFTP server in the grand scheme of things. So what did we see? What do I want you to do with it? We kind of laid the foundation here. We saw what CME, the vision of it is. We're going to have this single device supporting an entire office of IP telephony phones and linking it to the rest of the world. We then saw some of the characteristics of the phones that we need to look out for as we're buying them, and then we moved into the boot process itself, which we're going to continue to break down. Now, what do I want you to do with it? I would like you to do two things. One is start to put together a lab environment. Now, I'm not requiring you to go buy things. Don't think, oh, well, Jeremy said I had to, mortgage my house or nothing. I mean, don't go buy things. Just put together what do you think you would need. Like if you were to build a lab right now, and you were going to say this is what I would have. Go on Cisco's website maybe, or go on eBay and start looking and putting it all together because that helps you say, do I understand even the components that I need? All the components that I'm going to need to put together this voice over IP network. And spec it all out. See what the cost would be for a lab environment for your business, for a lab environment for your house. From there, I want you to then regurgitate that whole boot process. You should be able to pull up a piece of paper or a notepad on Windows or something and just say step 1. Phone requests, or I shouldn't say phone requests. Man, I'm off already. Switch delivers, detects and delivers power over Ethernet. Switch delivers voice VLAN. You should be able to just, you don't need them word for word, but know what happens and what order it happens in of that boot process, and then jump into the configuration in the next nugget. I hope this has been informative for you, and I'd like to thank you for viewing.